Okay, everything.
Yeah, you can.
Great. Okay, hi everyone. So in this lecture, we'll be talking about and introducing a lot of concepts involving the flow of data across the web. So in particular, we'll be discussing HTTP and introducing you to APIs and promises. But first, we have a message from our sponsor, Moby, who makes a lot of web lab possible. So Moby builds technologies that expand the human ability to navigate the world. Moby's core ability is to model decision-making through a planning platform to solve complex problems for the individual and at scale that the human brain can't solve alone. Moby's AI planning platform integrates robust data sets capable of fleet efficiency, optimization, business process automation, as well as guiding travelers to the tastiest meals and off the beaten path experiences worldwide. Moby's ability to solve tough problems at scale is being used by the world's largest brands. Founded in the research labs of MIT in 2012, we work, build, and learn together at our headquarters in Somerville, Massachusetts. We're proud to be backed by an outstanding group of investors, Firefly Venture Partners, RPM Ventures, and Enterprise Holdings, who share a commitment to building transformative travel technologies. So thank you to Moby for sponsoring us. All right, so let's get started with the content for today. So thus far, you've been introduced to a lot of important concepts involving designing and coding the user interface and layout of your site. You've built Tapbook, which is a static website, meaning that it doesn't really change with user data. So at this point, we're missing something. And why does our website not really change with user data? And how can we make it dynamic? So the reason for this is so far, we've really just been discussing the front end portion of designing a website. And the front end is the part that users directly interact with. So you can think of the front end as involving designing and building the layout of your website and making it user-friendly. And today we're going to be introducing concepts related to the back end of your website. And the back end is going to be the part of the website that handles a lot of the data storage and processing, as well as connecting and communicating with the rest of the web. So you can think of the front end as a sort of abstraction for users that simplifies a lot of this complex underlying logic that the back end handles. So the front end, we're really just concerned with user experience and designing a nice user interface. And in the back end, we'll talk about how the flow of data works and how we can connect and communicate with other people on the web. Okay, so in particular today, I'll be introducing how we can send and receive information from the backend. But before we continue, let's go over a few important terms. So we'll be throwing around the terms client and server, as well as requests and responses a lot today. So what exactly is a client? Well, for our purposes today, you can think of a client as being you and your teammates' browsers. And you and your teammates' browsers will then make requests to what we call a server. And very often this request happens when you just type in like a URL, let's say on Google Chrome. And that sends over a request for usually a web page to a server. And the server is going to receive that request and send back a response. So usually requests from clients are requesting something like a resource or some information or a web page. And once the server receives this request, it will then send a response with that information or resource or web page in the form of HTML, CSS, and JavaScript. So how is this information actually sent across the web? So we talked about how clients send requests to servers and how servers send back responses to clients. But how do we actually send this information? Email is clearly not acceptable. We can't just have clients email a server every time it wants information or a resource. So how we actually handle sending information across the web has to do with a very specific type of request and response, which is HTTP or HTTPS. So what exactly is HTTP? HTTP is short for Hypertext Transfer Protocol, and you've probably been using HTTP requests and responses the entire time you've been using the internet. Anytime you go to your browser, which we talked about is the client, and you type in some URL in your browser, that sends over an HTTP request to a server that is hosting the web page that you're looking for. And once the server receives that request, it will then send back a response to your browser clients with all the information you requested. So in this case, most likely you requested a web page, and it will send back the HTML, CSS, and JavaScript that your browser will then display as the web page. So HTTP is very important, and you probably use it every day. And HTTPS is basically HTTP, but with the added layer of security. So it stands for HTTP secure. And basically HTTP secure uses encryption for secure communication over a computer network. And HTTP requests and responses are highly structured, meaning that they have a very specific format. And enforcing this format on your requests and responses makes it a lot easier for the code on both the client and server side to automatically handle these requests and responses. So let's talk about the format that you'll need to know for making HTTP requests and responses. So this is what an HTTP request looks like. So we can break it down into 4 parts. So first, you have the request target, or the actual URL that you're typing into your browser. And then we also have the specific HTTP method, as well as headers and body. So let's talk about each of these 4 parts that you need to know, starting with your target URL and query parameters. So when you go to a website when you go to a browser and type in a URL, you can break down this URL into 3 main sections. So first, on the very left, you have the protocol that you're using. So here the protocol is HTTPS, which remember is the secure version of HTTP. And the next part is the URL of the server or the target. So here that's going to be www.youtube.com. Specifically, we're looking at results on the server. And after that, we specify what we call query parameters. And query parameters sort of give additional context to the server for what exactly you're looking for, which will help refine their response. So here we're asking the YouTube server to send back to us all videos that have WebLab in their title or description. So that's what the search query equals WebLab means. So you can find the query parameters right after this question mark. So whenever you type in a URL, and you might have noticed that sometimes this URL has a question mark in it, everything after this question mark is going to be the query parameters. So this is what you need to know for a target URL as well as the query params. So after you specify the URL, you need to tell the server your specific HTTP method. And there's a few methods that you should be familiar with. The most important ones for our purposes are get and post. There's also put and delete, and there's a bunch of other ones too, but you probably won't really encounter them, especially in this class. So let's talk about get and post in particular. So the get method does exactly what it sounds like. It gets data. So in this previous example with this target URL, this is likely going to be associated with a GET request, where a client makes a request to a server to get data. So in this URL here, the client, our browser, is requesting the server YouTube to get all videos that have WebLab in them. And then the YouTube server will then send back to us these videos with WebLab in them, formatted nicely onto a web page. We also have the post method, and post also sort of does what it sounds like. It sends data. So it sends data from a client to server, and you can think of an example where, let's say you're building a website where you want your user to fill out a form with their information. So once a user fills out this form and they press submit, we need some way to get that data from the user to our server, where our server is going to actually store that user data, maybe do some processing or analytics with it. But we need some way to get that data from client to server. And you can do this through a post request, because in a post request, we're sending data from the client to server. Okay, so in addition to our target URL and HTTP method, we need to specify a header and body for our HTTP request. So the request headers provides additional context for your HTTP request, which will help the server process your request, basically. So it has a lot of what we call fancy stuff, and a lot of these are going to be defaults that you don't really need to worry about. But basically, there's additional information. For example, here is a header And this tells us additional information, such as the specific browser the client was using, as well as the language that the server should respond in. And it also has like a timestamp. So it just has a lot of like contextual extra information that might be helpful for the server. So we also have the request body. And the request body is what actually contains the data associated with your request. So if you're making a post request where you're sending data from the client to server, then you can actually put the data that you're sending from the client to server into your request body. And usually this is formatted as JSON, which is called JavaScript Object Notation Format. And a lot of how we communicate data over the web is going to use this format. So make sure you're familiar with it. And here's just an example of JSON. Really, JSON, you can think of as storing key value pairs in addition to arrays. So it sort of looks like a combination of Python arrays and dictionaries. And here's just an example where we have an array of what looks like a bunch of dictionaries or key value pairs, where you have keys such as name, language, ID, and so on, mapped to their specific values. Cool, so that's what you should know for how to format an HTTP request. And the HTTP response also has a very specific format that you need to know and follow. So HTTP response, in addition to also having headers and a body, it also has a status code associated with it. And what a status code does is it gives, when a server sends back a response to a client, it tells the client how their request went. Maybe their request succeeded, so everything went okay, or maybe some sort of error occurred. Either the client did something wrong or the server did something wrong, but something went wrong and the server wasn't able to do its job properly. And the status code will tell you sort of the general class of what might have went wrong, and it's very helpful to know the status codes to help you with debugging. So here are just some very common status codes that you might encounter. The first is a 404 status code. You might have encountered a 404 error in your time using the internet, but basically this just means it's a not found error, meaning that the client was able to communicate with the server, but for some reason the server wasn't able to find the resource the client requested. So this might be because you typed in your URL incorrectly, or maybe the server moved the resource to a different URL. So when this happens, make sure you check that you typed in your URL correctly and that your URL is up to date. You might also run into a 400 error, and this means that somehow your request was malformed or bad. So something happened, maybe you accidentally typed in an incorrect query parameter, or maybe you didn't format your headers or JSON correctly. So when you get a 400 error, that is likely you or the client's fault. And you have to check your request. Maybe you have some sort of syntax error. So check that and make sure you fix it in order to get over this error. So another status code you might get is a 500 status code. When you get any status code that starts with a 5, that means that it's going to be the server's fault that something went wrong. So 500 means that there is an internal server error. And maybe this happened because the server machine hosting the website that you requested crashed, or the script running the server crashed. So something went wrong on the server side. Another status code that you might get is a 200. And this just means that everything went okay. So when you see a 200 status code, you should be happy because that means your request worked. Okay, so there's a lot of status codes. I just went over some very common ones. But in general, you can group your status codes into these 5 main categories. And the main categories that you're going to see are ones that start with 2, 4, and 5. So if your status code starts with 2, that means that your request succeeded. If your status code starts with a 4, that means you did something wrong, meaning that's the client's fault. So likely you have to change something about your request in order to make it work. If your status code starts with a 5, that means that the server did something wrong. So if you're the client, you can't really do much about this because it's the server's fault that something happened. And you might just have to wait until the server comes back up again. And there's a bunch of other status codes too that you can see at this URL I linked. But these are the main ones that you should be familiar with. Cool, so that's how you format an HTTP response for the status code. We also have headers and body, just like with the request. So Similar to with your HTTP request, a response header contains additional information about the response that might make it easier for your clients to process your response. So it might contain information such as the type of response as well as the length of the response. So content type and content length. You also have a body, just like with your request. So in the response, the response body contains like the actual information that the user requested or the client requested. So for example, if the client made a GET request for some sort of information, then that information will be included in the response body. And again, usually the response body is formatted in JSON. All right, any questions? Cool. So your requests are just out of sight. If you open up some random page, you can try this with your cat book website that you just made too. If you can open the developer section using Control-Shift-I or Command-Shift-I or whatever shortcut works for you. And you should see a network tab. If you open the network tab and refresh the page, you should see all the requests that went through to make basically your website load at the beginning. So here's just an example of what you might see. When you open the developer console, there should be a network tab at the top. And if you open the network tab, you should see all these requests that are going through, as well as their status codes. So you can see a bunch of status codes here. There's a lot starting with 3, and we also see some 200s, which is good. So this page might be helpful to you when you're debugging your website because it tells you like which of your requests are going through, which ones aren't. So if you see any like 400s or 500s here, that probably means you need to fix something. Cool. So in summary, one key takeaway here is that you are using HTTP every day. Anytime you type a URL into a browser, this sets off a GET request that very often responds with HTML, CSS, and JavaScript, basically anytime you want to visit a web page. All right, so now I'm going to hand it off to Jay, who's going to use a lot of the concepts I talked about with HTTP, as well as GET and POST requests to talk about APIs.
Okay, this should be on now. Cool. All right, so APIs. API stands for Application Program Interface. And in short, it's a set of endpoints that a service is going to let you make requests to. You might wonder, why do we need this? Why can't we just access the data on the service directly? We'll get into that. Companies like Google, Amazon, and Facebook all give you APIs, and that lets you use their services. So for example, with Google, you could use that to authenticate, or with Google, so that way you don't write your own authentication. For Amazon, you could use it to place orders from sites that aren't Amazon if you wanted to have some integration with it. And for Facebook, you could use it to embed Facebook posts inside of your own web pages if you want to highlight them or somehow like share them outside of Facebook. One sec. Okay, so the point of an API, why can't we just access data directly? Well, we can't do that because it's inconvenient and it's pretty insecure. Let's say, for example, that we have Spotify playlists and we are protective of our Spotify playlists. We don't want anyone else to look at our private Spotify playlist because we don't want people knowing our music tastes. Well, if Spotify gave everyone access to all of the data, then anyone could read our playlists, and we wouldn't want that. So we want the ability to access our own data and to not have other people access our data. We can do that with API keys, which provide authentication, or other authentication methods that we can use with an API. Additionally, APIs are a nice structured place for you to send a request to. So what that really means is that you can have a list of API endpoints, and you can figure out what you can do with the service from that list, which is much more convenient than having access to the raw data and trying to do something with it, because chances are that if you want to do something with that data, someone else will have already had that use case and will have also like tried to do that. So what APIs let you do is they let someone providing a service write endpoints that they think are important. And with that, you can do most of the tasks you'll need to do. Sometimes you'll have to combine the endpoints, but that's fine too. And now you can do a lot of things by asking the right endpoint very nicely. But what does using an API actually look like? Well, first of all, APIs sort of act as this interface between clients and data. And this interface is convenient because it isolates the data from the clients. But when we're actually invoking this API, what we're going to be doing is we're going to be making an HTTP request, just like Helen was talking about. And it's going to be usually either a post or a GET. So this API endpoint is going to be a GET. And we're going to be accessing API add. What this API does is kind of implied by the name, like it takes two numbers and it adds them together and it gives you the result. So first things first, where does the input to this API go? In the URL or in the body? I think that it's going to end up being in the URL. The reason why is because with GET requests, you don't use the body, only use the URL for query parameters. The body is not actually observed in a GET request, only in a post. You should remember this because it's helpful when you're writing a server, which you'll get to later, and you're trying to use your GET requests or implement your API endpoints. Because if you try to read the body, there will be nothing there. So the input to our API, we can describe it like this: two numbers, A and B, and then our output is going to be some JSON object that maps result to a number. And that number it's mapped to is going to be A plus B. So with that in mind, I want to go through a little example of what invoking this endpoint looks like and what this endpoint's going to output. First of all, this is an example invocation. What's going on here is we're calling the endpoint with inputs 5 and 8. And we can sort of imagine the API is like this black box. We feed it A equals 5 and B equals 8, and it's going to give us out something of the format result number, or like result, and like map that to the output. So what's this going to output? Hold up 1 finger for the first one, 2 for the second, and 3 for the third. Yeah, so this is going to output 1 because it matches the structure of the output that the specification described. So another important part of APIs is that you have to actually specify how they work for future use sake, because without specifying this, it's going to be really hard to figure out what the API is actually doing or what structure you should expect. This would have been pretty difficult to predict if, for example, we didn't know that the output would map a field named result. If we didn't know that field name, we'd have to like first look at the output and then figure out how it behaved, which is harder than just documenting that. Sorry. So endpoints. First off, let's assume that we're in the domain of like where Catbook is hosted on Render, which is catbook 5bwk on render.com. So when you access the URL, you're making a request to an endpoint. This is even when you're loading a normal page. Like that's just a GET request. And when the page loads, that means that you got some 200 and some content came out, typically. So if we do a GET against /API/stories, that's going to be a GET request for all the stories. If we do a post request against API/story singular, that's going to be a post request to make a story. And we can have lots of endpoints under the same URL, but they must all have a different request type. So if we were to access API/comment, its behavior depends on if we make it a GET or a post. Making it a GET is going to retrieve a comment, and making it a post is going to create a new comment. This can be useful if you run out of names. Like it's possible that there isn't really a better name. I would argue that there's not really a better name for API comment for creating one. Like posting a comment is pretty clear. And there are lots of APIs that you can use externally for your projects in this class. We have, for example, the Twitter API, and all of these APIs are like usable from JavaScript with some functions that we'll go over in a bit. But there's a caveat. A lot of these APIs will require you to have some API key or a token. That's because they're worried about you overusing their API, and they're worried that you like actually have permission to do so. And they might want to charge you to use their API if you use it often enough. So this API key is usually some like large string, and it's going to go in your query parameters. or the body or the header of your request, depending on what the API says. You'll have to check the documentation. All of these APIs are documented. So if you wanted to use one, you could look up the documentation and you could figure out what you need to pass in to get what you want out of it, as well as like what functions exist for you to use or what endpoints. So to test an API, we have tools like Postman and Recmin. Postman is fairly nice because it actually lets us build like collections of API endpoints. And with those collections, we can like test our endpoints repeatedly. So if we know we're going to keep the same endpoint around, Postman is nice because we can build an example call for it and make sure it keeps on working. Recmin is faster to use, like it's easier to use, but it's much better for one-off demos because it doesn't really have the same organization facilities. And Postman is really nice when you're debugging something in your website and you're really confused why, when you make a request, this thing like something happens. And in Postman, you can make the same request as your code is making, and you can see what comes out before it gets like processed by your code. So we're going to preview making requests to APIs in JavaScript, and then we're going to cut it off pretty soon after that because it turns out that making requests to APIs uses this thing called a promise, and we're going to get into that more after lunch. The Web Lab staff have given you get and post, which are two functions that respectively make a get or a post request. So get takes first the URL, and then it takes your parameters, and the parameters are going to be a mapping from like the key to the value, and then that gets encoded as query parameters because we can't use the body of a get request for passing parameters. And then for a post request, we call the function very similarly, but this time they end up in the body. And note that the outputted request is a post and not a get. So that means that it'll like behave differently. In this case, the parameters, we could also add extra parameters and they would like just work, but it depends on what the endpoint wants. So in general, the second argument is going to be some object, and we're going to encode that object either as query parameters or as body for calling the API. However, when we try to console log the results of these functions, we actually get this object promise. And we expect to instead get like this data about who has the phone number 617-253-0418. But we actually get this object promise, which doesn't have any of that data. So how can we actually access our data? We'll talk about that more after lunch because it'll take a little bit. But there is a way to access that data, and it involves asynchronous programming. I'm going to restart one sec. All right, I'm going to hand it off to Mark for announcements about lunch. Oh, yeah. So we promise you lunch every lecture, and we're going to fulfill that promise. It will not be rejected. That will make more sense than like after lunch.
Okay, so I'm going to change this to 1:15. Please remember not to eat in the lecture hall, and please wait a second. So this is where we have the food setup. It's all on the left side. So close.
All right. So we're gonna get started talking about promises now, and we're gonna start with an analogy, and it will be food related, which is, I guess, thematic after lunch. So let's say there's some web lab restaurant, and to a customer, we make the promise that we will try to make a burger for them. Now, two things can happen here. One, we can succeed, and you'll actually get a burger. Option two, or well, we'll get into that. But notice here that we have this receipt, and this receipt sort of represents something the customer can like show to the front of the restaurant that they actually were promised a burger and they should get their burger. So a promise is kind of like that receipt, and I guess we'll see more why. But the point of this receipt is that eventually, or you can periodically check if your order is done. And similarly, we can do a similar thing with promises in JavaScript. Alternatively, we can fail to make the burger. We only said we'd try. So if we fail, we might have to call the fire department because we're not very good chefs. And the promise is fulfilled if you get a burger back, and the promise is rejected if the restaurant burns down, or really anything else bad happens. So why bother with this model? Well, first, let's think about what would happen if we tried to run a restaurant synchronously, with only the ability to like cook one thing at a time. So if we can only cook one burger at a time, we have to watch it cook the whole time. And while we're watching it cook, we're really doing like nothing while we could be working on something else. This is similar to how control flow and programs worked in 6100A, where when one function is running, nothing else could really make progress, even if that function is just waiting for something else to complete. We don't really like this model because this model like limits our throughput. If someone asks us for a lot of food at the same time, then we can only handle one of those orders at a time. So we have a real like limit on how much food we can make. And we'll still have that limit with an asynchronous process, but it'll be much higher. So with async promises, or with async processes, we can have multiple tickets at a time. We can, for example, have like an order for a burger and for chicken nuggets and for another burger. And we can work on all of those at once because making all of those to some extent requires some waiting. So while we're waiting for one, we can make progress on the other, which is pretty convenient because which is pretty convenient because we can handle lots of orders. And the ability to handle lots of orders, like, well, partially comes because we have lots of staff, but that's sort of different. The ability to handle lots of orders comes from the fact that while we're waiting, we can make progress in something else. So we're not stuck just completing one order and then completing the ticket and then getting the next one, because we can actually have many outstanding ones at a time. And now our throughput's going to be limited by how many people we have to make food, not like at max one per person or max one per restaurant. Promises let us do asynchronous processing, which lets us work asynchronously. And we can work like this is similar to the restaurant because we can, instead of serving a burger, tell you that we will eventually serve you a burger. And then you can like plan to do something once you get that burger, presumably eat it. Or we fail somehow. And if we fail somehow, you'll also know about it. So we'll also tell you that we failed and you can try to ask us for a burger again or go to a different restaurant. Now, get returns the promise. And there's a function called .then on promises, which is really how we interact with promises, or one of the main ways. .then accepts a callback function, and this callback function has a parameter story object. And the name of this isn't super important. It's like domain specific. But the point is that the first parameter is the result of the promise succeeding or fulfilling. So after the promise is fulfilled, if it's fulfilled, we're going to call this callback function. And in this case, that callback function is going to use the set stories hook to with story objects to update our state in React in this example. Additionally, .then returns a promise. So we could chain them if we decided that we wanted to do something else after setting the stories with the result of that. However, we'd have to return something out of this .then to have a meaningful value to chain with. So we'd have to like return what we wanted to use in the next promise. So to recap, get returns a promise, then does something when the promise succeeds, and like the something is defined by the function the user passes in. And the function the user passes in accepts one parameter for the result of the promise succeeding. There's also .catch, which is run when the promise is rejected. So what's going to happen here is if the promise is rejected, we're going to log the error message that came with it. The reason why that happens is because the parameter to catch is also a callback that accepts this time a function of a single argument, where that argument is some object representing the error. And we can use that error object to like diagnose what went wrong or by logging it, for example, so we can debug it later. Also of note is that when you catch, the promise that's returned by .catch will always be fulfilled. So you can't chain .catch because the first catch will always like catch the error, and then the second one will not have an error because the caught error is like assumed to be handled. We would instead have to use .then to like see what came out of the .catch if we did that, but that's not really great design. It's much nicer to like use the .catch to handle all the erroring in one .catch and not have things depending on it. Additionally, we could use .then with 2 arguments and it would behave the same or almost the same way. So the second argument to .then is optional and it can be a callback that behaves much like this argument to .catch. There are slight differences, but they're not super important. I think the form that like you should use for simplicity's sake is the 1 argument .then and the 1 argument .catch because it's probably easier to understand. So to recap again, get returns a promise, and then if it succeeds, we set the stories to whatever we got out of the promise. Otherwise, if the promise is rejected, we catch the error and log what went wrong. Now back to like the motivation for promises. Calling an API takes a while. It can take like about 200-ish milliseconds to talk to a server because you have to go over a network and wait for the server to finish what it's doing to actually like serve your request. So when we have a promise that will resolve in 1 second, we can do other things while waiting for that promise to resolve. And you can see that here. So we define this promise, which is called which is coming from a function my1second promise that's going to return a promise that resolves in a second. And then with what came out of it, with what it resolves to, we're going to log that. And after doing that, after defining that promise and arranging all those callbacks, we're going to log some other messages. The order these messages come out in is actually going to be those first 2 messages here, and then what came out of the promise, because the promise started, but once it had to wait for a second, we were able to run the console log. So promises will, while they're waiting, let other code progress, which is very convenient when we're making API calls or doing other things that are slow. So what's going to be printed in this example? This promise below is going to reject. And roughly, what this function f is doing is given a promise, first it logs A, and then it logs B, because the first .then will run before the second .then, because the first .then has to resolve before the second .then can resolve, therefore it'll run fully. And if it fails, we're going to log error. So given that the promise is something that's going to reject, what does f of promise actually do? Like, what's going to happen? Hold up 1 finger for the first, 2 for the second, 3 for the third, or yeah, and so on. I'll give you a little bit. Keep in mind this promise is going to reject. I just want to remind you of that. But all right. So since this promise rejects, we're going to see only error. The reason why is because the promise rejecting like means that none of these .thens actually run, or none of the callbacks defined in these .thens run. Are there any questions about that before I move on? Hmm? Hmm? Like, why wouldn't we use if else to see if the promise succeeded? If we used if else, we wouldn't be able to run other things while waiting for the promise to complete. Because if else is like synchronous and promises are not. So here's another example. The promise below is going to resolve after like some time, longer than console log takes to run. Given that, we have the same function here. It's doing the same thing. First it logs A, then it logs B. If it fails, it logs error. And we're going to call f of promise. And then we're going to call console log hi there. And here we want to know what's going to be printed first. So same thing here. One finger, two finger, one finger for the first, two for the second, and so on. I'll give you a little bit again. Yeah, nice. It's two. So the promise takes longer to resolve than the console log takes to run. So we log something, and then the promise resolves, and we go through our chain of .thens, logging A and then B. And that's all I have for examples here, actually. So I think we can hand it off to the next workshop. But if there are any questions about this, definitely feel free to ask on the question doc or put yourself on the help queue if it's like something related.